Hello, my name is Gary Grimes. I'm the Director of Sales for RF Solutions for Optical Zonu Corporation. I'd like to spend a few minutes to talk to you about our antenna extender line of products. The antenna extender works in conjunction with standard cellular wireless repeaters, or RF boosters. The repeater is a product that is used to bring coverage, wireless coverage, into areas that are otherwise in shadow. Shown here, for instance, if you're on the roof of this building, you have a clear signal coming from the nearby donor site. The repeater connects to an antenna that's on the roof that has that strong signal. It brings it inside, amplifies it, splits it, and routes it to multiple antennas that are distributed around the building to ensure you have uniform coverage. That's on the downlink. And then in addition, it picks up the user's cell phone signals wherever they are in the building and brings it together and amplifies that and sends it up to the donor antenna where it sends it off to the donor site. So such a product, for it to work correctly, first of all, it must be filtered so that it passes only the bands of interest and you're not amplifying any extraneous signals or causing jamming to any other site. You also must have balanced coverage. That is, the range of coverage for the downlink signal must equal the uplink range. And finally, the product must be FCC approved to be used, just for the guarantee that it doesn't have any jamming on any other surfaces. Here's an example of a top-end consumer product from Wilson, the Wilson Pro, as shown here. You see the kit, which includes the repeater itself, and along with the coverage antennas, which are shown at the bottom, the small round ones, which are mounted in the ceiling and connect to the repeater with those coax cables shown in the back. The cone-shaped antenna on the left is the donor antenna, which mounts on the roof and points towards the donor site. In some cases, the distance between the donor antenna and the location where the repeater must be installed will be too long to use a coaxial connection. This could be maybe 150, 200 feet. So the repeater needs to be close to the coverage area as much as possible to get the maximum sensitivity and the best downlink power. But if the donor antenna location on the rooftop is going to be far from that, then coaxial cable just won't work. It'll degrade the signal too much. So in that case, that's where the antenna extender comes in. So it's a replacement for this cable run that doesn't have that limitation. So we're talking about an RF over fiber connection between the donor antenna and the repeater that can be up to 1,000 feet and more. So this is a filtered connection, so it's RF over fiber, but it only passes the frequency bands of interest in this case. In this case, the commercial bands. So you see it's made up of two units. There's the antenna unit, which mounts outside normally, could be inside, but it connects to the donor antenna, and there's the equipment unit, which is connected to the repeater. So these are DC powered units, which can be powered locally, or in very often the antenna unit, as shown, is powered remotely over a hybrid cable, since the location on the rooftop may be far from a power source. So the bands are, the standard bands shown here are the 700, 850 cellular, PCS, AWS, and WCS bands. There's no adjustments to be made. It's a drop-in connection. And we do have other versions. We do have a version, for instance, which supports the 2500 megahertz TDD service of T-Mobile. We have a public safety version that covers the 700, 800 megahertz bands. And we have a version for Europe, the European 5 bands as well. The specs are shown here. You see that there's actually a loss in both directions. The gain, the losses are such that when we connect it directly to the Wilson repeater, that the entire kit is compliant with all FCC regulations. So the downlink, when you put that together with the Wilson unit, it's all compliant with the FCC noise limitations. And the uplink is such that it can take the maximum input power from the Wilson unit and still provides you with the max output of the unit itself, which in this case is plus 17 dBm. Since the maximum uplink output power is plus 17 dBm, which is the minimum requirement from the FCC, you generally want to put the antenna unit as close to the donor antenna as possible so that you don't incur any additional losses from another cable, coaxial cable connection. So this means the antenna unit is generally going to be outdoors. So the connections to the antenna unit must also be outdoor rated. So it shows, here's a couple of examples here of the hybrid cable that Optical Zonu provides. You can see the cable is a hybrid cable, so it has two fibers and it has two 20 gauge conductors for the DC power. So there's a breakout that splits the fiber and the DC, as you can see on the left. The optical connector is actually a dual LC APC connector. And then it's protected by that Senko boot. That's the Senko IP68 connector, which has that cover that twists on and seals the connection. Same thing with the Hiroshi DC connector, which also is an IP68 rated connector as well. So here's the antenna extender we were just talking about. You see two units here. This is the antenna unit, a little heavier because all the filtering is in this one. These happen to be the 5-band US commercial versions of this. And then the equipment unit, which connects to the BDA or the RF booster. So this goes to the booster, repeater, whatever, and this connects through here to the donor antenna on this end connector. So you can see they're outdoor rated. Now clearly the equipment unit is generally going to be mounted, of course, is mounted indoors most of the time. However, all the connectors, the packaging is all NEMA 4X, so it's completely sealed. So actually, even though, yes, if it's indoors, we have a dual LC APC connector here, which is inside this cap. So if it's indoors, you can use a standard LC APC. You can tell by the green color, it's an angle polish connector. And then the DC connection here. Antenna unit, same exact configuration. The standard antenna unit, the 4-pin Hiroshi connector, which is used for the DC connection here. It's an IP68 rated connector. It just pops in and twists on. The standard antenna unit minus 48 volts, and that's the reason is because you're trying to maximize your uplink output power, which means you want it to be as close to the donor antenna as possible. So most of the time, this unit, the antenna unit, is going to be mounted close to the donor antenna, which means it's going to be outdoors on the mast with the antenna. So it could be some distance away from the equipment unit, and there may well be no DC power out there. So we can actually provide a hybrid cable, which is an outdoor rated cable that has two fibers and it has two conductors in the cable, provides a single cable connection that will allow you to go over 1,000 feet if you need to. That's because the minus 48 volt can take a 12 volt drop, and there's a 20 gauge wire inside that hybrid cable. To give you an idea, this is an outdoor cable that we use. Now this one's not a hybrid cable. It's just it's the Senko boot. So if you see, we take this cap off here. First of all, you have to pull back the locking ring and then untwist this, and you see the connector inside. Now, obviously it comes capped for protection to the connectors, which are very sensitive. So you pull the caps off, and then on the unit, twist this off, and you can see there is a couple of lines here on the connector, and there's a line here on the connector on the unit itself. So that gives you an alignment. You slide that in, hold the boot back, and slide the connector in until it seats properly. it on and push up the locking ring, and it's sealed, so weatherproof. This one happens to be a 50-meter length. Like I said, you can go over 1,000 feet with this. And like I said, you can use an indoor paired dual LC APC connector here if you're just in a standard environment. In our public safety version of this, the indoor unit would also have to have the sealed connector as well, because both units need to be NEMA 4X for the NFPA codes. So these are the basic features of the optical Zonu antenna extender. There's another version of this that can be for distributed coverage. There are cases where there is a single off-air signal that is desired, but it needs to go to multiple locations. So there could be several Wilson repeaters or other repeaters that are connected to a passive DAS in multiple structures on a site. So for this, we have this distributed version, and you can see the antenna unit is connected to this passive optical component here. So on the downlink, this unit is a 1x8 optical splitter to route it to up to 8 locations. Here we're showing 4 connections, but it could be up to 8. On the return path, each one of the transmitters, the laser transmitters in each one of those equipment units on the right, is tuned to a different CWDM wavelength. So when the signals are combined by that unit, it's a CWDM multiplexer which is doing the combining. This makes sure that there's not going to be any possibility that the optical signals could beat against each other and cause some kind of degradation in performance. So because of the combined optical signal coming back to the antenna unit, the uplink signal is attenuated somewhat so that we're not overdriving the photodiode receiver in the antenna unit. We're also developing a public safety version for the 800 and 700 megahertz bands. VHF and UHF are channelized services, so we have these 12.5 kilohertz channels separated by 5 megahertz, which are all interleaved. So in that case, it's kind of problematic to do a duplexed port. So you really have to have a unit with separate transmit and receive antennas if you wanted something universal. So that is something we do not have at this moment. However, the 700, 800 is straightforward, as it's got well-defined transmit and receive bands. And the only other thing that is required, we have to make sure that the units are compliant with NFPA. That's the National Fire Protection Association codes. So that means both units have to be NEMA 4X. There has to be some basic remote monitoring to connect to an in-code enunciator panel. FCC, UL approved. So this is in process. It should be available sometime second quarter in 2021. We are also doing other versions of this as well. I do have a basic European version. It's being expanded from the 5 bands shown here at the top to also include the new band 78, which is the C-band auction that just closed in Europe. And you notice it is a TDD service, like the Sprint service is. But this is easily accommodated by the components in the antenna extender. As you can see, this requires that the laser and photodiode that are the standard units, which are 3 gigahertz, are replaced by our 4 gigahertz units in order to cover the band 78 as well, which is just standard product with us. You can also see that we're doing a Tetra version, which is to support the FDD Tetra variant that's used in Europe and elsewhere for public safety. So that's the basic overview of our antenna extender. If you have any further questions, you need some more detail, or you got a specific project that you need some help in designing, don't hesitate to contact us, and we'd be happy to provide you whatever assistance you need. Thank you.